Good afternoon to everyone. This is Dr. B. Polaiah, working as a professor in the Department of IT, Institute of Aeronautical Engineering, Hyderabad. As we are all aware about our discussion in ELRV, that is, we are in a continuation of our image processing syllabus, that complete syllabus wise, each and every topic wise, we are discussing elaborately. So today also we are going to be knowing one of the topic that we called as color models of image processing. So this color model of image processing, how can we define actually? So image processing usually is to concentrate not only black and white, that is grayscale image, okay, but also color image, okay, color image. So how this black and white, nothing but grayscale. Black and white is nothing but grayscale images. So we are processing such a image processing. Basically, how we are processing in the sense when we are concentrating such a color spaces are different types of color models used in image processing and signals and systems for various purposes. Some of the common color spaces are RGB, and the second model is CMYK, and next one is HSV, and last one is YIQ. These are all the models, what we call as color models. The meaning of color models which we are concentrating here is basically we are concentrating in terms of color spaces. That means you want color, you want to change from one color space to the other color. So we are proceeding with the help of interns which we are defining color model. So that means what we want to understand from here, such a achromatic versus chromatic. Achromatic light, avoid that in the sense, chromatic light means void of color, only attribute is its intensity measured by gray levels. For example, black and white TV. TV is nothing but television. That is the kind of images that we discussed so far. So second point is chromatic light, nothing but wavelength. That is approximately 400 to 700 nanometers. So such a three basic quantities are used to describe the quality of chromatic light sources. So what is the chromatic light sources which we are concentrating is here? Approximately 700 nanometers. That means the radiations which we are concentrating is total amount of energy that flows from the light source in watts. So that total energy is also is one of the source which we are concentrating in terms of color spaces which we are converting into the color models. So that means how we are concentrating such a color models and color spaces in the sense we are concentrating in terms of not only what we call the radiations, but also we are concentrating luminance, brightness. So one of the you're going to be concentrate is that amount of energy an observer perceives from a light source, that is in terms of in lumens, that is LM. For example, far infrared light has large radiance, but an observer would hardly perceive it. That is called the luminance. Whereas brightness is nothing but similar to the achromatic notion of intensity. One of the key factors in describing color sensation is brightness. So based on what we are concentrating such a color models in terms of primary colors versus secondary colors of light, that is primary colors which we call as red, that is we simply call RGB. R means red, G means green, the B means blue. That is noted note in terms of notationally RGB component acting alone cannot be generate all spectrum colors. That is the point what we were concentrating here on the topic of color models of image processing. So we have secondary colors. That is, the primary colors, of course, RGB, but we have secondary colors also. That means the secondary colors which we are considering here in terms of you are converting from primary to secondary. How in this sense? Let you see. For example, you are going to have a color model in a secondary model, that is magenta. Is is the color which we are getting from primary colors by the combination of red and blue. That is, red and blue we call as RG, red and R plus B. Similarly, cane means G plus B. G plus means green and blue. We can concentrate here. So that is cane. Next, yellow, R plus G. So what do you mean to understand this? This is nothing but mixing the three primaries white light, then we'll get your required color. This we simply write as one of the model we called M, C, Y. Sometimes we may repeatedly we call as CYM also, CYM color also, because we have here one of the CMYK. K is the factor which we are mixing the approximated value in terms of white light. So that we can add here K, CMYK. Okay, so that what we are understanding from this slide. So we are understanding this slide. Main important point is how we are converting from primary colors to secondary colors. That is very important. So primary colors versus secondary colors, which we are considering in terms of pigments, is here magenta, cyan, yellow. So that means you simply say in terms of definition, by observing a primary color of light and reflected or transferred the other two, that is nothing but second colors, that is RGB. So we got this in the sense by comparing primary colors versus secondary colors in terms of pigments. So which we are concentrating much more on now. What we are concentrating here, RGB stands for red, green and blue, which we discussed earlier. But here such a RGB, how can we state as a model? That is simply we says what RGB model states that each color image is actually formed of three different images, actually formed into three different images. That is, simply we say from R we call the red image, from B nothing but blue image, that is we call as a black image. So what you need to understand here, a normal grayscale image can be defined only one matrix, that is but a color image is actually composed of three different matrices. Here suppose for example instead of black we also can write green image. Okay, so what is the difference between grayscale, that is grayscale nothing but we called as a grayscale, we called as a black and white also, black and white image. This we can form within a one matrix. But whereas RGB color we have different, that is minimum three matrices, because three colors are different. But where in case of grayscale image we called only one, that is called black, by mixing it with white. So that's what we are, one color image matrix is equal to red matrix plus blue matrix plus green matrix. That is what we are understanding. Of course, we are here how those we can segregate, or those in terms of separate. We can understand that in terms of RGB colors. How we are, these colors are forming in terms of red, green, blue. So how we are going to be concentrating this sense? We are converting such a color image processing in terms of red to, you are converting into required color. That is, this is red. This is red. Okay, and remaining things are black. That is completely avoiding. So and, suppose green. For example, this is green. This we are going to be converted into required green color. So that means blue. Blue is here. Blue is here. So what you mean to understand from here, in the sense you are required colors of the models we are ready to form in terms of your RGB colors models, which we are going to form into your required formation. And second thing is, once we understand such a what we call such a color models, how from primary to secondary we are converting in terms of required formation of your required formation of image, nothing but application of RGB colors. That is common applications of RGB model are which we are going to be concentrating here. Number one, these RGB model are cathode ray tube CRT, and second one is liquid crystal display, that is LCD, and next one is plasma display or LED, what we call LED display such as a television, and such a television, that is we call as TV image processing. Next, computer monitor or large scale screen, which is we are understanding in terms of any theaters screen. Maybe they're maintaining that illuminator brightness approximately 75 mm. 75 nm. So what do you mean to understand from this is nothing but we are going to be concentrating on completely in terms of your required formation. So this is the best what we can understand the application of RGB, how we are concentrating in terms of required formation. So for example, when you are concentrating such a color combinations, in the sense basically a image which we have, this is image in terms of either 2D or 3D image. Okay, because we know the basic definition of image based on the 2D or 3D image may have that complete matrix values, maximum of maximum, minimum of minimum. That means you are going to be change that minimum to maximum any values in between 0 to 255. That means you may be change either 256 or if you neglect 0, we will take only 255. So we have the you wanted to prepare one of the model color model, we called as, this is color model, we called as YCM, otherwise we simply say as per our definition of CMYK. Okay, where K is the additional mixed color in terms of white. So C means can, M means magenta, Y means yellow, and K value is which we are defining in additional parameter. So this model, how we convert by the help of RGB, that is from primary colors only we are supposed to be preparing your required color combination model. That is what we call as green, red. By mixing these two colors, nothing but two images, we will get the yellow image. And green plus blue will get cyan. Keep in our mind is one of the important point is by the mixing of green and red images we will get yellow. By the mixing of green and blue we will get cyan. By the mixing of red and blue we will get magenta. By the mixing of red and green we will get blue or else white. So these three will mix, then we will get the K value. So like that we are preparing the model. Model is nothing but which we are apply towards to your required manner, your required formation. Coming to the CMYK is nothing but what just we discussed about. The conversion from RGB to CMY is done using the simple method which we previous slide we done. And whereas CMYK color model is widely used in printers, especially in printers, it stands for cyan, magenta, yellow, and black. Nothing but key value. Key is always black. That is what we simply write here CMYK. K is the key factor. that may be black, obviously. So it is a subtractive colored model which represents the primary color as 0, and 1 represents the latest color. That is, we simply say 0 is represent primary color, 1 represents the lightest color. That is what we are observing from here. Okay, latest. So in this model, the point 111 represent black, 000 represent white. So that means what we understand, black and white. So it is a subtractive model. Thus, the value is subtracted from 1 to vary from least intensive to a most intensive color value. Most intensive color model. Next, for example, let us take one example. CMY, they given 3 images values. C for cyan, M for magenta, Y for yellow image. How we got these values? By the help of RGB. Okay. Consider we have an color image. Means you have 3 different arrays of images values: red, green and blue. Red, green and blue images. Now if you wanted to convert into CMY, here's what we have to do. We are going to be maintain the subtract it by maximum number of values minus 1. Each matrix is subtracted and its respective CMY matrix is filled with the resultant matrix. So that is simply we can write as a we are all concentrating programming wise. So simply we can say that is 1 minus RGB will get CMY. So C means cyan is a negative value, negative of red, magenta is a negative of green, yellow is negative of blue. If we implement this equation, we will get such a values. Okay. So how in the sense, let you see here very colorful models, RGB color models. Okay, or red green will have red green yellow. So here we will get from RGB to CMY. K is your factor. That is, forget about that. So that may be black. That may be black. So you may got this color alone. We got, what is this color? Blue. You got this color alone, magenta. This is magenta. Yellow, you know. So red, you know. How you got yellow? Magenta plus yellow. How you got cyan plus yellow is green. Cyan. So how we got this colors of the models from the RGB only. From RGB only. So by the subtraction, that is, cyan is a negative of red. Negative of red. So magenta is a negative of green. Where is green? Here. So like that, we can form your required model, which we call as from the color model is RGB to CMY. So let me see the examples of the color image. For example, we want to find from high res, okay, or fingerprint. Okay, so this iris values, okay, iris values which we are concentrating, okay, fingerprint. What for you want color image? For example, you wanted to keep in terms of finding certain information from one to other. Example, we may be access, as you all of you know, Aadhaar card scanning and all. Aadhaar card information is we have in terms of 2 ways. One is thumb or iris. So iris is concentrating in terms of your required color processing, required color model, which the model which its failure of iris, then automatically they will going to concentrating on fingerprint. So based on this, we are obviously following your CMY K colors, color model. So like that, we can proceed by the help of certain samples. For example, how we maybe proceed that sample. Let you take the input image as your fingerprint. and you may apply your color model, then you may going to have your required print. But here we may also process this color model by the help of wavelet packets. That is separation. Wavelet is nothing but separating each and every part of the image. So your image A and image B, how you convert into your required model of the, in the sense we divided image, you are divided the particular image into your required model. So you are basically you have RGB model. Okay, from this you may be converted into CMY. Okay, and including key factor also. So like that, even color for full color models of image processing also we can concentrate from your required manner of models. Or in the sense for the finding of certain information, hidden information we can find. So with these references, even I'm encouraging you all not only to concentrating on my complete courses which we are discussing right now about color models of image processing, but we can refer this with the help of references where we can see this digital image processing by uh, Rafil. It is one of the book which encourages us to write programming also. So by the help of Jayaraman textbook, we can concentrate much more on problems. We can concentrate here some problem solutions. We'll get problem solutions. So I'm encouraging all of you, please follow these two as our prescribed textbooks. And I'm very thankful for your patient listens. Really, I'm very happy to share my complete video to all, and it will be continue in coming classes also for with other topic by the see the importance of these color models of image processing. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.